In this lesson, we're going to talk about how to perform a site survey. At this point, your network design should be complete, but it may not be accurate because of various conditions that you just can't account for on paper. To determine what these conditions are, you need to conduct a site survey. In a site survey, you visit each location where an access point will be installed, determine what the RF environment looks like, and then actually set up a temporary wireless network to see how the radio signal behaves. There are several things you should do. First, inspect each mounting location that's in your on-paper plan. Basically, we're making sure we can physically mount an access point where we want to. You may encounter situations where you just can't mount an access point due to a variety of structural or environmental factors. Next, identify and document structural or environmental concerns that may disrupt the RF signal from the access point. Then verify that you can reach your wireless controller from the location. For a wired backhaul, you need to be able to run a wire to the controller. For a wireless backhaul, the access point's wireless signal needs to be able to reach either the controller itself or another access point that can relay it to the controller. Next, assess the availability of power and grounding for the access point. After you've inspected a location and determined that it will work, log its GPS coordinates. You should also take digital photos to document each mounting site and its surrounding area. During the site survey, you should bring actual access points to each location to test the signal quality and identify the node density required in each area. Remember, the specifications for your access points are determined in a lab environment. A real-world environment adds factors that you can't anticipate in a lab, so you have to evaluate how well they perform on site. Be aware that a site survey takes time, equipment, and at least 2 people to complete. Your site survey kit should contain several things. First, you'll need 2 access points and 2 laptops with a network performance measurement utility such as LPerf installed so you can evaluate the network throughput available at each location. You also need a tall ladder so you can test each AP at height or close to height. During the site survey, you won't physically install each access point. Instead, you'll use a ladder to approximate its final mounting location for testing. In outdoor deployments, you may need to rent a bucket truck for this step. And then you'll need 2-way radios to communicate with your assistants and a spectrum analyzer to perform a spectrum analysis. The site survey test procedure involves these tasks: mount, align, test, move, test, and then perform the spectrum analysis. When you test communications between wireless devices and the access points on your wireless network, you should be concerned with the concept of goodput. Goodput refers to the number of useful bits delivered from the sender to the receiver over the wireless network connection within a specified amount of time. Errors due to lost packets, corrupt packets, or dropped packets will require retransmission and hence reduce the goodput of the connection. You should use a spectrum analyzer at different times of day to check channel utilization and identify sources of RF interference at each location where you plan to deploy an access point. You can use freeware tools like NetStumbler to create a snapshot of wireless spectrum usage in your area. It'll show you how much nearby home and business networks use and how close they are to your network. When you perform your spectrum analysis, you should record the number of other APs in the area. Record channel utilization in the 2.4 and 5.x GHz bands to aid in channel planning. When you run your spectrum analysis, you should gather data at 2 locations. First, at the height where you'll install the AP, and then at the height where you'll install user devices. A spectrum analyzer can provide a reading of the noise floor in the desired frequency range so you can pick the best available wireless channel in the area. To do this, you should identify the minimum signal to noise ratio, the SNR, and received signal level parameters, or RSL parameters. As you can see in this diagram, the RSL just identifies how strong the radio signal is at the receiver. The closer you are to the transmitter, the stronger the RSL. The farther away you are, the lower the RSL. The SNR measures the level of the wireless network signal, the RSL, and the level of background noise in the decibels, and then it compares the measurements. Any SNR higher than 1:1 indicates more signal than noise, which is what we want. The farther you get away from the transmitter, the lower the RSL and the lower the SNR. As soon as the RSL falls below the noise floor, you lose connectivity. You should use your spectrum analyzer data to develop a channel plan that will work in your environment and take into account all of the frequencies that will be used. Most access points and controllers can support both 20 MHz and 40 MHz channels in the 2.4 GHz and 5.4 GHz ISM bands. Remember, using the 2.4 GHz band provides only 3 non-overlapping channels at 20 MHz and only 1 non-overlapping channel at 40 MHz. This increases the likelihood of adjacent channel interference at 40 MHz. In fact, you should probably avoid using 40 MHz at 2.4 GHz for 802.11n deployments. The 5.4 GHz band is much wider and handles 40 MHz channel bonding a lot better. The next step in the site survey process is to plan the core network. You should identify the IP addressing scheme and the VLAN configuration that you'll use. When you design your VLAN configuration, be aware that you could end up with a large number of wireless clients all in the same VLAN. This can result in an excessive amount of broadcast traffic within the same VLAN. To fix this, you can create many smaller VLANs. This will reduce broadcast traffic, but it will also require additional routers to route traffic between VLANs. You can also implement VLAN pooling. In this configuration, each wireless client is randomly assigned a VLAN from a VLAN pool on the same SSID. This strategy automatically partitions a single broadcast domain into multiple VLANs. Use this information to create a logical network diagram that can be used during the actual deployment of the wireless network. After these tasks are done, you should have a pretty good idea of what equipment you'll need to deploy the wireless network. Using the network diagram you've created, which takes into account node density and spacing, you should be able to identify how many wireless controllers you need, how many access points you need, and what media you need to implement, such as UTP for the backhaul. Use this information to generate an equipment list. If you think you'll need spare devices, account for them in the equipment list as well. When this is done, you should create a site survey report that contains several items. First, a physical network diagram, including each access point, controller, and the media that connects them, an RF model that includes a frequency channel plan, spectrum analysis results, a logical network diagram containing SSID, IP address, and VLAN information, and photographs and diagrams for each access point mounting site. You'll also need a list of structural modifications required to build the network, a list of alternate mounting locations, a list of equipment you need to purchase, and a cost estimate for equipment and labor. That's it for this lesson. In this lesson, we discussed how to conduct a site survey. We identified the testing equipment, testing procedures, good put, and how to perform a spectrum analysis. Then we discussed how to create a channel plan, a core network plan, an equipment list, and a site survey report.